In this video, I'll be working through the Gauteng Maths Grade 10 Term 1 2023 Common Test. So this paper was for 50 marks and it was written in 1 hour. Now let's have a look at question 1. So you know the format of your test, that question 1, question 2 will be on algebra. And in 2023, the sections covered were the same, where it was algebra and then trigonometry. So this paper, just like the previous video that I've posted, would be really good practice and really good revision to help you prepare for your common test for this term. Okay, let's have a look. So question 1, it says, given that we've got p is equal to the square root of 9 over 11 minus x, where x is an element of negative 11, negative 5, 0, and 15. So what does this actually mean? We are given values of x. And when they tell you that x is an element of, and you notice that you've got values within curly brackets, that basically means that those are all the values that represents x. So here we have 4 values that x is represented by. And now they say for which value or values of x is p a rational number, an irrational number, and non-real. So let's do this, right? Separately, we are going to substitute all 4 values into x in this equation that's given, and let's see what it gives us. From there, we are able to know which value it would be rational, irrational, and non-real. So let's work in the space that we have here, and I'm going to start off by substituting the first value, which is negative 11. Since there is already a minus in front of x, we're going to substitute negative 11 into a bracket. Now let's simplify this. Well, you can go ahead and just put the whole thing on your calculator, but if you do that, make sure that you put it exactly as you see it with these brackets as well. Now when you calculate this, you get 0.639. So if I round that off, it is 0.64. But here's the thing, right? We are trying to see which values are rational and irrational. So remember that rational is any answer that can be written as a fraction. So when we check out this answer, we cannot get it as a fraction. It is a long, non-terminating decimal number, and we don't have it as a fraction. So that is actually irrational. Where this is the answer that I had, 0.639602149, and it does continue, right? It's non-terminating. So we know that when x is negative 11, that gives us an irrational answer. So the irrational part is actually asked in 1.1.2, but I'm just going to fill it in as we go along. So here we have negative 11. Now let's try out the next one. We're going to try out negative 5. So here I have it. I've substituted negative 5 in place of x. Now let's put this on the calculator. And we get a fraction. We get 3 over 4 or 0.75. But the fact that it can be written as a fraction, it tells you that, 3 over 4. The fact that it can be written as a fraction, it tells you that it's rational. So when we substitute negative 5, it gives us a rational answer. So rational is for 1.1.1. Let's fill in negative 5. Now let's try out 0. Now substituting 0, we get 0.904534,033. It is a long, non-terminating decimal. And we do not have a fraction version of this answer, which means that when we substitute 0 for x, we get an irrational answer. So for 1.1.2, there were actually 2 answers. It's negative 11 and 0. Now we're going to try out 15. And when you try out 15, you get a math error. Math error means that the value does not exist. It is non-real. So this is actually undefined, or we can say no solution. And I actually just want to show you why this happens. When we simplify that denominator, 11 minus 15 gives us negative 4. So what we have underneath the square root is a negative fraction. And we know that the square root of a negative value does not exist. So for non-real, x is 15. Okay, so if you get something like this, no matter how complicated this given equation is, all you are doing is you're substituting values of x into x in your equation, and you are assessing or you're analyzing the answer that you get. Now let's work with question 2. So 2.1 asks you to simplify the following expressions. 2.1.1, we have a binomial being multiplied by a trinomial. And what's going to happen here is each term in your binomial, so starting off with this x, it's going to multiply with all 3 terms in the trinomial. And then the negative 2y is going to multiply with all 3 terms in the trinomial. So I'm going to write this above. I'll put the answer here. Now to start off, we're multiplying the x, so we're going to have x times 2x, which gives you 2x cubed. X times positive xy is positive x squared y. X times negative y squared is negative xy squared. We're now taking the minus 2y and multiplying into the bracket with all 3 terms. Negative 2y times 2x squared is negative 4x squared y. Negative 2y times positive xy. So firstly, negative times a positive gives you a negative. And that's going to be 2xy squared. Negative 2y times negative y squared is positive 2y cubed. So we have multiplied out completely, and we are now going to gather like terms. Now to gather like terms, we notice that there is only one term that has x cubed in it, so that will stay as is, 2x cubed. Looking at the next term, we have x squared y, and we notice that there are 2 terms that actually has x squared y in it. We've got positive x squared y minus x squared y. That is going to give us negative 3x squared y. Going on to the next term, we have minus xy squared. There is a like term, we've got minus 2xy squared. So here's 2 like terms. Gathering those, we end up with negative 3xy squared. And then there's only one term that has y cubed in it, so that's going to stay as is, 2y cubed. So here, we've simplified 2.1.1. It cannot be further simplified, so this should be your final answer. We are now on to question 2.1.2. And what we notice is that we are dividing 2 fractions. Now here's the thing when it comes to fractions. Whether you are adding, subtracting, dividing, multiplying fractions, your first step is to make sure that each part of your fraction is fully factorized. So if we have a look at the numerator here, we've got x squared minus x plus 1. Yes, that is a trinomial. Yes, it is quadratic, but it cannot be factorized. So we're going to leave that as is for now. Now looking at the denominator, you've got x cubed plus 1. That format is sum of 2 cubes. So we know that for sum of 2 cubes, we open up 2 brackets. One bracket gets a binomial, the other bracket gets a trinomial. And I've actually shown you in the previous paper that I've done, so the previous video, how we do this. So I'm just going to go ahead and apply it. To get the binomial, we cube root the first term, we cube root the second term. To get the trinomial, remember the trinomial depends on the binomial. So we square the first term, we multiply both terms together, and we change the sign, and we square the second term. And there's something interesting that emerges once we factorize. We realize that the trinomial in the numerator is exactly the same as the trinomial in the denominator. Once you have factorized, if you have any factors or any brackets that are the same, they can cancel out with each other. So here the numerator cancels out with that bracket in the denominator. And now we are dividing by the second fraction. But here's the thing about dividing fractions. You learned this in primary school as well. If you are dividing two fractions together, your next step is to change the division into a multiplication, and your second fraction gets inverted, meaning that your numerator and denominator swaps around. So what we're going to have in the numerator would now be x squared minus 1, and we would have 2 in the denominator. But with the x squared minus 1 in the numerator, that can be factorized because that is in the format of difference of two squares. So we know how to factorize that. We open up two brackets. Each bracket will get x and x since it is x squared. And the square root of 1 is 1, so we'll fill in 1 and 1. One bracket gets a plus, the other bracket gets a minus. Now here is the thing about multiplying fractions. When you multiply fractions, it is your permit for you to cross-cancel. If any of your numerators and your denominators are the same, or they have the exact same brackets in them, they can cancel out with each other. In the second fraction, we're left with x minus 1. And in the denominators, nothing left in the first fraction, but in the second fraction, we have 2. So here's your final answer. It is x minus 1 over 2. You will be allocated marks for all of your factorizing, for changing the division into a multiplication, for showing what you are cancelling. And please remember that when you are cancelling out terms, you use a single diagonal line to show that it's being cancelled. Please do not scratch over it as if it's a mistake. That would be wrong. Remember, the person marking your script still needs to see what's written underneath that line. And then 1 mark for your final answer. Now, question 3. It says simplify the following. We have 5x to the power 0 plus 5x all raised to the power 0. So we need to understand the difference between these two, right? We know that from laws of exponents, anything raised to the power 0 is 1. So we've got 5 being multiplied by 1. This x to the power 0 is 1. On to that, inside the bracket we have 5x to the power 0. Now, no matter what you have inside the bracket, as long as it is raised to the power 0, it is equal to 1. So this entire term here is equal to 1. Now to simplify this, 5 times 1 is 5. So we have 5 plus 1, and 5 plus 1 is 6. It was only 1 mark, so I actually prefer when you show your working out so you understand what you're doing and what rules you are applying. But it was probably 1 mark just for the final answer. Now we're on to 3.1.2. And for questions like this, when it comes to having the variable as the exponent, we want to make sure that the bases are products of prime numbers. So we've got 8. We can actually rewrite that. It doesn't have n as the exponent, so it's not necessary. But if you change it, it doesn't really affect your answer, right? So 8 can be written as 2 cubed. That is being multiplied. I'm just going to rewrite this time sign as a dot by 3 to the power negative n. Now, in my denominator, I notice that my bases are prime numbers, so that's fine. However, if there is a base that has more than one exponent on it, meaning that its exponent is 2 separate terms, or more than one term, we should say, we need to split it up. We can rewrite that as 3 to the power negative n times 3 to the power positive 2. And why are we allowed to do this? It's basically your first law of laws of exponents. We're working backwards here. When you multiply bases that are the same, you add the exponents. So here, 3 and 3, if we multiply them, if we're multiplying bases that are the same, we're going to add these exponents, we end up with negative n plus 2. So it gets us back to where we were with what we were given, right? Now the next one we have is 3 to the power negative n. And this is important. Why do we split up the exponents. Why did we do this? Doing this allows you to identify what is common in your terms. So by doing so, we realize that both terms contain 3 to the power negative n. So we're going to factorize. And listen, it's not necessary for you to factorize your numerator. Why? The reason is because this is seen as only one term. Remember, terms are only separated by a plus or a minus, which means that your denominator has 2 separate terms. If you want to cancel out something, you're not allowed to. You have to factorize first. So pulling out 3 to the power negative 1, in the first term we're left with 3 squared. In the second term, it's minus 1. Now at this point, the 3 to the power negative n from the top cancels out with the 3 to the power negative n from the bottom. And if we simplify this further, here's what we get. 2 cubed in the numerator is 8. 3 squared is 9 minus 1. We have 8 over 8, which is essentially 1. So our final answer here is 1. Now for 3.2, we need to solve for x, and again, x is the exponent. And we know that for these type of questions, where x is the exponent, your first step is always the same. Get your bases to be products of prime numbers. So the left-hand side is fine because 2 is a prime number. But the right-hand side where we have 8, 8 can be rewritten as 2 cubed. Now this is something you actually learned last year, that when x is the exponent and you're trying to solve for x, once your bases are the same, they cancel out with each other. And we equate the exponents. So we have x plus 2 is equal to 3. And from here, it is so simple for us to solve for x. All we do is take the plus 2 over to the right. It's going to minus. We've got 3 minus 2, which is 1. So therefore, x is equal to 1. We're now on to question 4, and 4.1 says solve for x. So in 4.1.1, we have 15 minus 3x is equal to 2x minus 25. We know that when we're trying to solve for x, our aim is to get x alone on the left-hand side. So let's actually start off by taking this negative 2 over to the left. When it goes over to the left, it is going to subtract. So we'll have negative 3x minus 2x. And let's take all of our constants over to the right. At the moment, we've got a negative 25 on the right. When this 15 goes over to the right-hand side, it becomes negative. Remember, whenever you take a term over the equal to, so to the other side, the sign changes. Now on the left-hand side, minus 3x minus 2x gives us minus 5x. On the right-hand side, negative 25 minus 15 is going to be negative 40. Now to get x alone, you are going to divide both sides by the coefficient of x. So here our coefficient is negative 5. On the left-hand side, they cancel out. We're left with x. On the right-hand side, we've got negative 40 divided by negative 5, which is going to give you 8. So the answer is x is equal to 8. Now we're working with 4.1.2, and we've got inequalities. So when you have inequalities, especially this kind where you've got 2 separate inequalities, your aim is to get x alone in the middle. And whatever you're trying to cancel out, you have to cancel it out throughout, meaning that we're going to start off by trying to get rid of this negative 7. Now how we do that is we'll have to add 7 throughout. So to show that you're adding 7, it's not necessary as a step, but I've just written it down so that you can understand exactly what we're doing. We are trying to cancel out the minus 7 from the middle. So we'll add 7 throughout, meaning every single side, the left, the middle, and the right. Now on the left-hand side, we have negative 3 plus 7, which gives you 4. In the middle, minus 7 plus 7 cancels out. You're left with 2x. On the right-hand side, 7 plus 7 is 14. Now to get x alone in the center, we need to get rid of its coefficient, which is 2. So we're going to divide throughout by 2. Doing so, we have 4 divided by 2, which is 2 on the left. In the middle, the 2's cancel out. We're left with x. On the right-hand side, 14 over 2 is 7. So this is your answer. Now, going on to 4.1.3. This question, so we've got 2 brackets. And please do not make the mistake of multiplying out the brackets. If you do that and you get the like terms, yes, you will have a trinomial. But you'll have to factorize a trinomial and you're going to end up back at this point. So instead of going around in circles, we can just work with it from here. They have factorized for you. And once you have your brackets after factorizing, you take each bracket and you equate it to 0 separately. So we have x plus 5 equals 0 or 2x minus 8 equals 0. Now working with the first part, we can take the 5 over to the right-hand side. It becomes negative 5. And in the second part, taking the 8 over, it becomes positive 8. And then to get x alone, you're going to divide throughout by 2. So x is equal to 4. So those are your 2 values. X is equal to negative 5 or x is equal to 4. Moving on to 4.2, we are given that 3x is equal to 12, 2x plus y is equal to 2, determine the value of x minus y all squared. Now here's the thing. This is the type of question where you are actually solving simultaneously. Actually using both your equations to solve for x and y. Once we have the values of x and y, then we will substitute it into this format and get the answer. Now let's start off with that first equation. So they gave us 3x is equal to 12. And what we notice here is that we can immediately solve for x if we divide both sides by the coefficient of x. So dividing both sides by 3, we have x is equal to 4. Now that we know what x is, we can substitute it into the second equation. So we have 2x, which is going to be 2 times 4, plus y is equal to 2. Simplifying, 2 times 4 is 8. We have 8 plus y equals 2. Taking the 8 over, it's going to be 2 minus 8, which is negative 6. So we now know what x and y is equal to. And we can work with the format that they've given us. They want us to find out what x minus y all squared is. Let's substitute. X is 4 minus y is negative 6. I'm going to put that in a bracket because there's a minus in front already. And don't forget to square. Let's just simplify what we have first. So negative times a negative is positive. We have 4 plus 6, which is going to give you 10 inside the bracket. So essentially, I'll continue here. You've got 10 squared. And 10 squared is equal to 100. So that would be your answer. Once you solve for x and y, substitute into that format and get your answer. Now we're on to 4.3 and it says given E is equal to a half mv squared plus mgh. They want you to make V the subject of the formula. For those of you who take physical sciences, this formula is known as mechanical energy. It is something that you're going to learn about next term. But it's not necessary at the moment for you to know what the formula is for. That was just an extra bit of information. What we need though is to make V the subject. So what does it mean to make something the subject of the formula? It means to get that value or that letter alone on one side. So we want to get V alone on one side. Now, since V is on the right hand side, we can keep it there. So to start off, I'm going to take this term, mgh, over to the left. Since it is positive on the right, when we take it over to the left, it becomes negative. So we've got negative mgh. That is equal to a half m v squared. Now in the next step, you want to get v alone on the right hand side. So you don't actually want this a half m. So what are we going to do about that? To get rid of the half m, we are going to divide both sides by a half m. So here we get e minus mgh over a half m, and on the right hand side we have a half m v squared over a half m. What actually happens here on the right hand side is the half m's cancel out. Since they cancel out, I'm just going to erase them, and we are left with v squared on the right. But we have v squared. We need to get v alone, so we need to get rid of the square. How we get rid of a square is we square root. But here's the important thing. Since it is an equation, what you do on one side, you must do on the other side as well. Now, square rooting, what actually happens on the right hand side, we said the square root and the square cancels out. So we will have v alone. Now you can keep v on the right, or you can swap them around. You can put v on the left. And what we are now left with is the square root of e minus mgh all over a half m. So this is our final answer. We've now made v the subject of the formula. Let's now look at 4.4. It says Gauteng saves 1 rand and 2 rand coins in his money box to buy 60 rand data bundles. He counted 34 coins after opening his money box. How many 1 rand coins were in his money box? Now there's two separate bits of information that they're giving us. Firstly, we know that together there are 34 coins. But there's a 1 rand coin and there's a 2 rand coin. So we need to have two different letters to represent each coin. Let's go with x and y. So let's start here. We'll say let x equal the 1 rand coin and let y equal the 2 rand coin. Now I'm going to focus on the information where they said that he counted 34 coins. So the number of 1 rand coins plus the number of 2 rand coins together in the box gives you 34 coins. That's the first equation. But there's also something else that they said. They said that he saves these coins to buy 60 rand data bundles. Also, I've just adjusted this because I didn't write it down. We said x is representing the number of 1 rand coins and y is representing the number of 2 rand coins. Now, focusing on the part where he's trying to buy a 60 rand data bundle. In order for him to save up 60 rand, we don't know how many 1 rand coins and how many 2 rand coins he needs to save. But what we do know is that x is representing the number of 1 rand coins. So since x is the number of 1 rand coins, we can say 1x plus 2y is equal to 60. Now let's make sense of this, right? Why we've got 1x and 2y is that we've got the 1 rand coin, but there's an x amount of it. And we've got the 2 rand coin, but there's a y amount of it. Because remember, those letters represent how many there are. Now what we actually have here is we've given ourselves two equations. So we have a system of equations where we can solve them simultaneously to get the values of x and y. Now I'm going to start off with the first equation. I'll make x the subject. I'm going to take the y over to the right hand side. I've got x is equal to 34 minus y. At the moment I know what x is, so I'm going to substitute here. Since it's 1x, we can just look at it as being x. We have 34 minus y plus 2y is equal to 60. Gathering like terms. Minus y plus 2y is y. Taking the 34 over to the right hand side, it is going to subtract. So we get y as 26. Now that we know what y is, we can substitute into the previous equation to get x. We have 34 minus 26. So x is equal to 8. Here is our answers. X is 8, y is 26. But let's go back to the question itself. They asked you, how many 1 Rand coins were in his money box? X represents the number of 1 Rand coins. Y represents the number of 2 Rand coins. So we can say, therefore, there were 8 1 Rand coins in his box. We're now moving on to question 5, and this is based on trigonometry. It says, in the diagram below, the angle that P, so P is a point here, we've got 12 and y, makes with the positive axis is theta, and OP is 13 units. Now, firstly, you're given point P, and 12 and y are given as a set of coordinates. So it's made up of an x coordinate and a y coordinate. What we need to do is create a triangle out of this. So I'm going to take this point P and I'm just going to drop it straight down to create a right angle triangle. Now what's important here is that the x value or the x coordinate represents your horizontal distance. So this horizontal distance, the horizontal side of the triangle, would be 12. Your y coordinate represents your vertical distance on the triangle. And here we can see that the hypotenuse given is 13 units, which they're calling OP. We also have this angle theta. Now it says, without the use of a calculator, determine, and the first thing they want is the value of y. So we need to ask ourselves, how can we calculate the value of y? We've got a right angle triangle. We know two sides of the triangle, but this third side is unknown. Immediately, you should think of the theorem of Pythagoras. So let's use that. So theorem of Pythagoras is r squared is equal to x squared plus y squared. Remember, r is your hypotenuse, so that's going to be 13 squared. X is the horizontal distance, so that's going to be 12 squared. And y squared is unknown. Let's just simplify. 13 squared is 169. 12 squared is 144. Now, to get y squared alone, let's take that 144 over to the left. It is going to subtract. We get 25 is equal to y squared. But to get rid of that square, you are going to square root both sides. Here's something important. When you square root a value, the square root gets a plus or minus in front, meaning that this answer for y could either be positive 5 or negative 5. But you choose the sign of your answer based on where your triangle is. Since we are in the first quadrant and we're dealing with positive y values, y is going to be positive 5. So that is your answer. Y is 5. So on our diagram, let's fill this in. We've got y as 5. So we now have all three sides of our triangle known. Now for 5.1.2, they want sine theta. So remember that sine is opposite over hypotenuse. Here opposite is 5, hypotenuse is 13. So sine is equal to 5 over 13. Now 5.1.3, let's write this down. We need cot theta over cosec theta plus 3. Now here's the thing, cot and cosec are reciprocals. And I've mentioned this in the previous video as well, where cot is 1 over tan, and cosec is 1 over sine. So where you would normally have tan being opposite over adjacent, cot is inverted. Cot would be adjacent over opposite. So cot here is going to be 12 over 5. And for cosec, cosec is 1 over sine. Now normally for sine you would have 5 over 13. But cosec has it swapped around. Cosec would be 13 over 5. Then we have plus 3. So here's what you can do. I know they say without using a calculator, but you can use your calculator to simplify this. When you simplify the first fraction, you get 12 over 13 plus 3. And 12 over 13 plus 3, when we calculate that, gives us 51 over 13. So that is our final answer. The reason why they say do this without a calculator is because they actually want to see your substitution. So you'll be awarded marks for substituting, where here it would be 1 mark for each substitution. So 1 for 12 over 5, 1 for 13 over 5, and 1 for your final answer of 51 over 13. Let's now go on to 5.2, simplify without the use of a calculator. We have sine squared 60 degrees times sec 45 degrees. Firstly, the angles that we have, 45 and 60, those are special angles. And we know that for special angles, I've shown you in the previous video the table that we use to get the values. I'm just going to put it up here. So this is the table that we use, and it allows us to get all the ratios for 30, 45, and 60. Now let's start off by substituting. The fact that we have sine squared 60 tells you that whatever answer you substitute for sine 60, it has to be squared. Now we go to 60 degrees. We know that sine is opposite over hypotenuse. So sine 60 would be square root 3 over 2. Then that is being multiplied with sec 45. Now sec is the reciprocal of cos. So where cos is adjacent over hypotenuse, sec is hypotenuse over adjacent. So let's go to 45. Let's go to hypotenuse and adjacent. That gives us square root 2 over 1. Now simplifying this, when you square your first fraction, that is going to give you 3 over 4 times square root 2 over 1. And simplifying this, you can put it on your calculator. It will give you 3 square root 2 over 4. Again, they say without using a calculator because they want you to show your substitution. But to simplify to get your final answer, you can use your calculator for that. I'm just going to move this above so that I have space for the next question. Okay, there we have it. Now, we no longer need this table for special angles, so I'm going to remove that. Now, 5.3 says, given 3 cos x is equal to 2 and x lies between. So this is how we read this, right? X lies between 0 and 90. What that means is x is a value that is between 0 degrees and 90 degrees. So x is actually an acute angle. Now they say determine the size of x correct to 1 decimal place. So we need to actually solve for x. And if we look at what we're given, we have 3 cos x is equal to 2. Now just like algebra, if you're solving for x, you need to get x alone on the left hand side. So we're going to start off by getting rid of the 3. And how we would get rid of the 3 is we would divide both sides by 3. On the left hand side, you will be left with cos x. On the right hand side, 2 divided by 3 is just 2 over 3. Now since we need to get x alone, we don't want this cos next to it. So what do? We take cos over to the right hand side. And here's something extremely important. Whenever you are solving for an angle and you are getting rid of a trig ratio, in this case we have cos, when you take it over to the right hand side, it becomes cos to the minus 1. If it was sine, it would be sine to the minus 1. If it was tan, it would be tan to the minus 1. And what goes in the bracket is the fraction that you had. Now, how do you put this on your calculator? You are going to press Shift cos. When you press Shift cos, you will have cos to the minus 1. You fill in 2/3 in your bracket, close the bracket, and get your answer. Now here, they wanted the value of x correct to 1 decimal place. So let's see what we get. Now firstly, we get 48.189. If we were to get this as 2 decimal places, it would have been 48.19. However, we need this as 1 decimal place. So we're going to look at the second number, and if it's 5 and above, it changes the number before it to the next value. So this is going to be 48.2 degrees. Now, how do we know that we are correct? It's because they said that the value of x needs to lie between 0 and 90. We do have an acute angle, so that's fine. Now, moving on. It says hence. Now, here's the thing about maths. Oftentimes, you'll have questions that say hence. Hence means using your previous answer. So using your previous answer, meaning where we had x as 48.2 degrees, we're going to use that to answer the next 2 questions. So they want to know, what is cos 2x? So that's going to be cos, and we open up the brackets. This is basically 2 times the angle, so 2 times 48.2. Let's put that on our calculator and see what we get. Cos of 2 times 48.2. They don't really give us a restriction on the number of decimal places, right? So I'm going to go with 2. I get negative 0.11. Now let's try out the next one. We have 2 cos squared x, and it's going to be 2 cos squared x minus 1. So we just substitute the value. Let's put this on our calculator. Okay, but here's something that you might be confused about. How do you actually put this on your calculator? This is how we write it out, but the way you put it on your calculator is a bit different. So you're going to say 2, and when you press cos, your calculator automatically opens up the bracket, so it doesn't give you a chance to fill in the square at the top. But this is what you do for the square. The square tells you that this entire cos 48.2 is squared. So when you put it on your calculator, press 2, open up a bracket, then press cos. Fill in your angle, close the bracket for the angle, close the bracket for the cos, so for the whole thing, and then square it. Okay, so that's how you put it on your calculator when there is a square on your trig ratio. And then you say minus 1. And what we notice is that this also gives us negative 0.11. So both those answers ended up being the same. Now the last question, 5.4 says, what conclusion can you make from question 5.3.1 and 5.3.2? So based on these 2 questions that we just answered, what conclusion can we make? Since we saw that they both gave us the same answer, it means that they are equal to each other. So the conclusion that we can make is that cos 2x has to be equal to 2 cos squared x minus 1, since they have the same answer. Okay, so that is it. I will be posting more videos on Term 1 maths papers, so please be sure to check out those as well. If you found this video beneficial, please like, share, and subscribe. Thank you.